Kevin with the 3.
Here's something.
Sorry?
Gavin had to pull out his fingers and toes just to do that.
Theorem, what's a theorem? Rule that has to be proven true. Alright? I know we haven't talked about it for a while, and I think I told you at the beginning that every time we took one of those definitions, tests, or quizzes, theorem would be on there, and then I lied because it wasn't on that one that we've taken about 12 times now. Alright? No, it's going to be on there a lot now. So theorem, a rule that has to be proven true. What's the other word that goes along with theorem?
Well, not that one.
You're right. I'm just
The
mad
one
at
that's
myself.
not true.
What's a postulate? Because it might be on the next one.
Another
It's a rule, but instead of having to be proven true,
rule. Possibly.
we just take it for, we assume it to be true. We take it for granted that it's true. So theorem has to be proven, postulate we assume to be true. Midpoint, we did this definition, set of notes last time. What is it?
It divides something into 2 parts. Like a
Splits the segment into 2 congruent segments. Supplementary angles. 2 angles that add up to 180. Questions on page 293. Problems you want to see worked off of it. Yep, it's in great shape. Number 6. Make sure you got out your calculators. I think starting next class, I'm going to start taking calculators for a grade again, because I got a lot of people not bringing them anymore. Or at least, I don't know, maybe they're bringing them, just not getting them out when they should get them out. My eyes aren't working very well today, so if I write something wrong, somebody please tell me. Is that what that one says? We had a theorem last time. Dealt with these kind of angles. This angle is called what kind of angle? Exterior. And that theorem said this exterior angle equals what? The 2 interior angles added together. So 58 should equal x plus x. What is x plus x? Somebody help me out with their calculator. 29? What'd they ask us to find?
The measure of angle S is at the bottom one.
Bottom right.
This one?
Yeah.
So if x is 29, what's this angle? 29 degrees. Next question. .2. In triangle RST, what's the first thing I'm going to do before I can go far? And what am I going to label it? Now, looking at my triangle, apparently this triangle is equilateral, correct? We don't know that, do we? Please don't assume stuff like that. When Jameson draws himself a triangle,
I was emailing the teacher and I just got a response. You want to see it?
no, that's when you put your phone on.
He said we have until Monday.
When Jameson draws himself a triangle, he's either going to draw a right triangle or an equilateral triangle 99.9% of the time. Does that, no you're not. Does that mean that it is an equilateral triangle? No, don't go by what you draw, go by what they tell you. And what did they tell us in this case, so I don't have to try to read this?
The measure of angle T is 5 degrees more than the measure of angle R.
Okay.
And measure of angle S is 10 degrees less than the measure of angle T.
We don't know any of these angles.
So the R is that.
Put R, so make this our X, and then what they tell us about T?
Is 5 degrees more.
X plus 5.
So that'd be X plus 5.
X would be X minus 5. X minus 10.
So this,
X minus 10.
they said it was 10 less than T.
No, X minus 5.
X plus 5 minus 10.
Measure angle S is
Plus
10
5.
degrees.
It's 10 degrees less than this angle, right? So we're
Yeah.
taking that and subtracting off 10, which some of you have already done. We could put those two together, right? So it'd be X minus 5. Now what are we gonna do once we know each of those angles? You gotta set up an equation before we can solve it. What do we know about 3 angles of a triangle?
Out of 180.
So tell me the equation when we set up.
X plus X plus 5 plus X plus 5 minus 10.
Plus X minus.
Yeah. Equals 180.
Equals 180. How many X's we got?
33.
What happens with those two?
Cancel.
Cancel out. Now what? So X equals, on this one, what'd they ask us to find?
What was the measure of each angle?
So they wanted all the angles.
R is 60.
Measure of angle R equals 60 degrees.
S is 55.
Measure of angle S is right here, that's 60 minus 5, which is 55 degrees. And then what's the measure of angle T?
65.
Can we check our answer?
Yeah.
Add them all up, they should add up to how much?
180.
180. Do they?
Yeah.
Which one? 33. Uh, 33 says, right. Explain why a triangle cannot have an obtuse, acute, and a right exterior angle.
Because if there's an obtuse, acute, and a right exterior angle, that means that there's, like, you take the opposite of it, so there's an acute, obtuse, and right interior angle, and that's just like possible.
So if I draw my triangle here again, and again, Jameson knows just because I drew an equilateral looking triangle, that's not what it is, right? So this angle's acute, let's say, this exterior angle. This exterior angle, we'll say is obtuse. And then this exterior angle, we'll say is a right. Well, that means this is 90. What's this interior angle right here then?
90.
This angle out here is acute. What's that make this angle in here?
Obtuse.
Will that work?
No.
Can a triangle have a 90-degree angle and an obtuse angle? Give me an obtuse angle.
147.
91. What's 90 plus 91?
180.
So how much would this angle have to be if that was the case?
Negative 1.
-1. Probably not. So that's sort of the explanation of it. Can't have, if you have an exterior angle that's acute, then the interior angle is going to be obtuse. If you have an exterior angle that's right, then the interior angle is going to be 90. You can't have an obtuse and a right angle in the same triangle.
Not enough degrees.
Next question. 21. Triangle DEF. Again, drawing some picture here, doesn't matter what the triangle looks like. Says the measure of angle E is 3 times the measure of angle D. Measure of angle F is 9 less than the measure of angle E. What is the measure of each angle? Which angle we gonna let be our variable this time? Or different things?
D.
D? So let it be X. Let's see if that works. So, measure of angle E is 3 times the measure of angle D. So what's angle E gonna be? The measure of angle F is 9 less than, be careful. 9 less than measure of angle E. So we know 9 means 9. What's less than mean? Minus angle E, what do we say about it? But less than also tells us that we have to do what? Got to switch the order. Make sure you know with less than, Grant, got to switch them. If I say 3 less than 7, what number's 3 less than 7? All right, you had to switch them around. Not negative 4, 4, right? So you had to switch them around. So what's going to go in here for F? Set up our equation. Can we collect like terms before we do this so I don't have to write so much? How many x's we got? 7 x's. Minus what?
9.
Should equal?
180.
So this angle plus this angle plus this angle should equal 180. What's that give us?
189.
Well, I bet all of you can do that in your head, right? 27. Everybody agree with that?
Yes.
What'd they ask us to find?
All the angles.
You're kidding me. What's this angle?
27.
This one? 81? What's the easiest way probably to find this one? 'Cause I don't know.
It's 70.
Well, I guess we just did do 81, so 81 minus 9 is, that's not too hard. I was gonna say it's probably easier to add these two up, subtract from 180, but since we'd already did 3 times 27, which only Cooper knew off the top of his head, nobody else would know that, because he's such a genius.
My sister is.
Compared
Well,
to
it's
English.
not-
Actually, telling.
Actually,
No change if you take it down.
well, that too.
Other questions?
30.
30.
Didn't help you out?
30 is the last one.
She said she'd go,
It's gonna take me a while to draw it. Good one to end on too, because it's going to lead us into part of what we're going to do today. I'm not putting any numbers on here. We're going to find every angle in this picture. I don't care what angles they ask you about. We're going to find every possible angle. And I'm going to tell Zach right now, when you're doing a problem like this one, if they ask you, find angle 1, find angle 2, find angle 3, it's always, I don't know, I shouldn't say always, 99.9% of the time, it's easier to go through and find everything you know, then answer the questions. All right? You start off, and Ebersole's a jerk, and when I put this on the test next time, Ethan K., the first angle that I ask you for in a picture like this one, it's going to be the hardest one to find. So Ethan's going to be looking at it, and he's going, and then he's going to not find all the rest of them because he gets frustrated on that first one. Find all of them you know, then answer the questions. So just look in here. Tell me an angle that we can find.
The one by the 30 and 1
So what's this?
20.
20? Everybody agree with that?
Vertical angle 110.
About this one right next to it?
70.
How about this one?
70.
There's a 130.
It's the wrong direction, I guess.
And you can find.
Did I miss something?
There's another 130.
Where I?
Vertical.
Oh, okay, I see what you're saying. Now, you gotta be careful with that.
Or,
No.
no.
Doesn't work out, does it? Because it doesn't, this doesn't extend down. But,
That one right.
how much
there
is this whole thing?
160.
160. It's those two put together, isn't it? There you go. Is that all we can find? Are we done?
You,
What if I just did this and just drew the triangle?
Or you can do the other. You can do one in the corner with the 110 and 30.
yeah, you can do that
40.
one. It's on the left side.
Like right here.
Down.
Down.
Left.
Oh, so this middle triangle.
Yes.
Yeah.
All right, since I already drew the big triangle off, let's do this first, then we'll come back to that one. What do I know in this big triangle, if you get rid of these two lines cutting across through here?
Bottom right is 50.
Bottom right's 50.
And the other two are congruent.
So how can we find that?
180 minus 50.
So they're both 65.
So each one of these has to be
Wait,
60.
never mind, that was wrong.
Is that wrong?
Wait.
No,
Yeah, that's
you're
right.
right.
So this angle up here is 65. Now this is gonna lead us into, so listen closely, because we're gonna be rushing through the notes today. And we'll probably get to this, but we may not. Anybody tell me what kind of triangle I did draw here? Now Jameson could sorta say, Ebersole, this time you did draw, but it's not the one I've been saying. Because it's not equilateral. One of the theorems that we're gonna cover today tells us if these two angles are congruent, guess what's true about the sides across from those angles? They have to be congruent. What kind of triangle is that in? It's an isosceles triangle. Now let's go back to this triangle that you guys picked out here.
That's 40. The ain't missing is 40.
That's 40 over there,
You can find the bottom triangle
the
too.
bottom triangle. Since we found that was
Yeah,
65 and 20.
No, because there's 3 angles. And you're missing 2. Never mind. Yeah, you're right.
65 and 20. That's 85. How much is this angle then?
95.
95.
And you can find the top triangle.
Top triangle. 65, 70, and we're missing this, so 65 plus 70. What's that?
135.
What's left over for this then? 45.
That's everything.
What's this angle out here?
40.
This angle? 95. This angle? 45. Is that every angle? No, we're missing one.
Bottom.
Missing that one, aren't we? 20? Everybody agree with that? Vertical to that? Is that all of them? I'm not sure which angles they asked you to find, but we just found them all, so should be able to pick your answer out from there. Again, I don't know how long it took us, it took us about 30 minutes to do that problem, didn't it? 2 or 3 minutes, and we found all the angles. So I need to time it next time, Nick, so you understand what 2 or 3 minutes is. If it was 5, you'd been able to trace that bridge more times than you did. On the notes, if you didn't grab the notes, go up there and grab them. Second set of notes for this 9 weeks. Make sure you're keeping your binder in line. Unless your name's Cooper, because he always gets the free binder, because he's my favorite.
Is it my hand or straight? That's mine.
Over here. Well, we're going to deal with congruent polygons. Congruent polygons, dealing with identifying corresponding parts, using corresponding parts. And then there's a third angle theorem that we're going to talk about. Congruent polygons. Congruent polygons, write this right there with this top part. Same shape, same size. Ignore that. What determines the shape of this triangle? Hold on, I gotta get rid of that one. Wrong color. We need orange, don't we? What determines the shape of the triangle or shape of any figure?
The size.
The angles. The angles determine the shape, all right? What determines how big or small this triangle is?
Size.
The size. That works for any shape. How big it is, how small it is. Because I'm showing you this triangle, then I show you this triangle. They're the same shape. And the reason they're the same shape is because what's true about the angles in it? They're the same. The angles in this triangle are the same as the angles in this triangle. But they're not the same size. All right? That's because the sides are different lengths. So anytime you're dealing with congruent, we don't want something like this. Congruent means that these two figures match up perfectly. All right? Fill in what you need to fill in on this part. The principle of superposition. Some math person was bored one day and wanted to sound smart, so they made up something stupid. Do I got something different?
No, you have
Yours
to
is
highlight
red,
it.
so I was like. So.
Highlight is different. Oh. Make it nutty. So, principle of superposition, all it means, if I take these two shapes and they're the same, they're congruent to each other, just matching them up. That's all that means. We're not going to deal with that a whole lot. It's sort of silly. To match up the shapes. If I got these shapes right here like this, I might just have to slide them together to match them up. What would I have to do to match the shapes up if I have them like this? Flip it over, fold it, something like that, right? What if I have them like, sorry, I just did the same thing. What if I have them like that?
Flip and fold.
How about rotating? Would that work? So that's what you got to be able to do. You got to be able to match up the shapes, make sure that they match up.
Are we gonna play with those toys?
Yeah, you want to play with them? Will it help keep you focused?
Evan's never gonna flip it.
Yeah. That's right.
I keep it quiet.
I'm sure that's what his mom does at home.
And Brian books.
That's why you have so many toys.
Brian books.
No, it's 26.
When you're dealing with these properties, first of all, reflexive property, guaranteed. Quiz next time, everybody listening to this, except for Gavin who's busy with his triangle. On the quiz next time, guaranteed reflexive properties on there. What are you going to put down?
Anything equals itself.
Anything equals itself. All these properties work for triangles also. When you're naming these triangles, they have to match up. So when I'm looking at this bottom one, triangle ABC is congruent to triangle HGR. And you're going to have to match them up. This is called the congruency statement. We're going to talk about this here in a minute. It's called the congruency statement. You telling that these triangles are congruent. When you're matching them up, that tells you that if I look at my two triangles here, if this is angle A, this has to be what?
H.
This matches up to that. D matches up to what? G. And then C matches up to R. From the names, you can always just pick out what parts match up with each other. So I know that angle A, if these two triangles are congruent, angle A is always going to be congruent to which angle?
H.
A little harder. I know segment BC is always going to be congruent to what segment in the other triangle? Does everybody see that? So you could just use these names. They got to match up. That's going to be one of the key things today. Is you have to be able to match them up and name them correctly. Now when Bo goes and he names the first triangle, doesn't make any difference how he names the first one. What matters is that when he names the second triangle, he matches them up correctly. Two-angle theorem. Looking down at the bottom first. They tell us angle 1, mark your pictures the same way I'm getting ready to mark them. They tell us angle 1 is congruent to angle 4. So all you're going to do, put a little arc in angle 1, arc in angle 4. They tell you angle 2 is congruent to angle 5. So what am I going to do for that?
2 marks, mark with a line.
You could do that also. Jameson said 2 arcs first, so I did that. You could put the mark with a little tick mark, or an arc with a little tick mark on it. What this theorem says, if these two angles are congruent to these two angles,
So the last two have to be.
what has to be true about these two? They got to be congruent. So what are you going to write in this blank?
Angle 3 is congruent to angle 6.
Then angle 3 must be congruent to angle 6. Angle 3 must be congruent to angle 6. Anybody have any idea what goes in this blank? If what? 2 angles of one triangle are congruent to what?
2 angles.
2 angles of another triangle, then what was true? Then the third angles, or the third pair of angles, must be congruent. That's the 2-angle theorem. The 2-angle theorem. These 2 angles are congruent to these 2 angles, then the third pair of angles have to be congruent. If you're looking at 2 triangles, and I tell you that this angle's 60 degrees, this angle's 30 degrees, could you find that angle? And if I tell you this angle's 60 and that angle's 30, what's going to be true about those 2 angles every single time? They've got to be the same. 2-angle theorem. Two triangles are congruent if and only if all corresponding parts match up. So these 2 triangles are congruent to each other because they match up perfectly. All right? If I had these 2 triangles, they're not congruent. These angles match up. Those top 2 angles match up, don't they? They're exactly the same. But is the rest of it? So they're not congruent. So that's the only time that they're congruent, if everything matches up. Blank 2 angles or 2 segments that match up when congruent shapes are matched. This is, well, first let's talk about this before I write that down. We had this when we were dealing with parallel lines. Name me a pair of corresponding angles in that picture.
1 and 5.
What did you have to do to understand that 1 and 5 were corresponding angles?
Smash.
Smash them together, and they laid over top of each other, right? That's exactly what we're talking about here. When I take my two triangles, the corresponding parts lay over top of each other. So they're the parts that match up. They're the parts that lay on top of each other. So this segment right here in the blue triangle is the same as that segment because they match up. They lay on top of each other when you match up the two triangles. And all this is corresponding, just like the corresponding angles, only it's corresponding parts. So corresponding parts are two angles or two segments that match up. The congruency statement. Somebody name this first triangle down here for me.
ABC.
Boy, Miranda took the easy way out, didn't she? Now, what you got to do when you're naming these polygons and trying to say that they are congruent to each other, you've got to make sure that you match them up. What would I have to do to this second triangle to get it to match up to that one? My thing would quit switching. What would you do to this triangle to get it to lay perfectly on top of this one? Flip it, like reflect it over. What's going to lay on top of A?
W.
What's going to lay on top of B? T? Is that right?
Yeah.
And what's going to lay on top of C? That's what you got to do. Now, is that the only way that you could have named it? No, James didn't like the way that Miranda named the first triangle. How else could we have named the first triangle? Is that going to change the way we name the second one?
Yeah. DT does.
So C matches up to what? D. B matches up to T. And A matches up to any of those answers. Either of those answers would work. There's other answers that would work also. Just looking at the names there. Which angles match up? Pick me an angle in this first triangle.
A.
B.
Is it all right to name? I put angle B, sorry. I started to say, I was going to write angle A and then
Yeah, Miranda.
it was in my head.
So.
So angle B matches up to what in the other triangle?
Angle T.
So we know angle B is congruent to angle T. You could look at the names and just pick this stuff out. B matches up to T, so those two angles have to be congruent. Give me another pair of angles. Let's go through this pretty quick.
C.
C and D.
Angle C matches up to what?
D.
D. And the third pair?
A.
Angle A matches up to.
W.
So anytime we know these two triangles are congruent, we know all those things, or all those parts are congruent. What's the other parts that we know? If we know the angles here, what else do we know?
Line 1 is congruent to other line.
So all the segments, all the sides, right? Nick, pick me a side in this triangle.
AC.
Just makes Jameson happy when he beats you to an answer, doesn't it? He's just so tickled. Segment AC over here matches up to what in that other one?
WD.
And you can tell that they match up because they each have the one tick mark on it. WD. Sorry,
DT.
I can't read my writing.
DT. Oh, I did the other one. BC.
BC, so segment BC is congruent to what? BC has
BT.
3 marks on it.
Huh? I said BT.
BT,
BT is not on.
DT.
DT. And then what's the third pair?
WT.
I couldn't hear.
AB and WG.
AB and WT, everybody agree with that? Now, when you're matching up the segments, they don't have to go in the same order or anything as long as they're the correct segments. So it doesn't, if you switch this, Abby switched it and called it segment CA instead of segment AC, doesn't matter. Up here it does matter what order they go in.
We need to give Gavin triangles more often.
And he's been quiet, hasn't he? Told you. Next part. I hope he's doing his notes, him and Nick. I just said I hope, Nick. I didn't say you weren't. I just said I hope. We're not going to deal with this right now, but the book doesn't cover this, and I like it, so at the end of the chapter, we're going to throw in something over this. If I give you these two triangles and I tell you these two triangles are congruent, they match up just like they look like they should match up. Once I tell you they're congruent and I tell you segment AB right here is 10 centimeters,
And the age was 10 centimeters.
then that means this has to be 10 centimeters. All right? And that's sort of what CPCTC is. Corresponding parts, the parts that match up of two congruent triangles must be congruent to each other. CPCTC. Again, we're going to go over that later on in the chapter, but I just threw it in there. Do what?
Preferably not, Henry.
Put your notes away for a second. Get out a clean sheet of paper. Get out your books. Page 301. Page 301.
Ah,
Yep. This paper will be turned in here in just a couple minutes. And we're going to do it very, very quickly.
ah.
Right there.
Think if I give them a circle, they probably get confused.
You don't have it on forever.
We're talking about you.
I want a circle.
Gavin, you get lost in the circle here.
He'd never know when to stop, would he? On this, we're going to do these a little different than what the book says. The first one, we're actually going to do everything that the book wants. Second one, third one, fourth one, fifth one, however more for this part, we're not going to do it. This will be turned in, so make sure you're writing everything down. What did they tell us on this first one that I didn't put up here? I'm sure they gave us some marks. Angle A here, did they mark it?
Yes.
Yeah.
How many?
1,
This angle,
2,
this angle,
3,
this angle,
1, 2,
this, this segment, AC,
1,
AB.
1.
Now, what we want to do is we want to match up those triangles and write the congruency statement. So make sure that we match them up. Oh, hold on. I know the book gave you this, but I really don't understand why they did. We have 3 pairs of angles, so that's good. But we only have 2 pairs of sides. What's the third pair of sides?
The middle.
Middle. Explain more to me.
This line that goes through the middle.
So it's segment what and what?
BC.
Segment BC. I know this doesn't look exactly like that, but you need to be able to understand this for this whole chapter, because when we get to these 2-column proofs, this should be one of the easy steps in the 2-column proofs. What do you know about this side in the green triangle and that side in the orange triangle? Now they're congruent, but they're also
Same.
the same. They're exactly the same side. Name this side in this triangle. BC. Name this side in this triangle.
CB. Same thing.
Same thing, right? They're the same. Don't try to make it confusing. You're hurting Henry's brain. All right, so it's the exact same segment. Anybody know what property we're using there?
Square.
Anything equals
Itself.
itself.
But it's not. Yeah.
What if I do this?
That's just bigger triangle.
What do you know about?
They're the exact same.
They're the exact same. Anything equals itself. Those two sides equal each other because they're the exact same side. What if I do this?
Not in it. Now you're
They're
messing it
weird
up.
because you can't just like.
But what's true about this segment here and this segment in the green one?
Same.
It's the exact same thing. Anything equals itself. Silas, I'm telling you, these guys are messing around, but it's going to be important. That's going to be one of the easy things in the two-column proofs. Anything equals itself. You see something that looks like that, you're going to say, hey, I know that BC equals BC. Anything equals itself.
Ow.
Somebody name the triangle
ABC.
ABC. Now, be careful. What do we have to do to this triangle to get it to lay on top of this triangle perfectly?
Rotate.
Rotate it around. What's A match up to in the other triangle?
D.
D.
That one's pretty easy. Here's where most people mess up. What's B match up to?
C.
C.
Matches up to this one down here, doesn't it? And notice how they're marked. And then what's C in this triangle match up to?
D.
That's your congruency statement.
I'm a genius.
That's part of your answer.
Hard.
Yep. Want me to spell it?
I think W.
The other part that they wanted here was they wanted you to name all the corresponding parts, all the parts that match up. You could just use the names and do that. Angle A, what's angle A match up to?
Angle D.
Does everybody see that? What's angle B match up to?
Angle C.
And what's angle C in the first triangle match up to?
Angle B. Like last year or like
Ah,
random
now,
bonus?
that looks sort of stupid, doesn't it?
Yeah.
Reminds me of Henry.
So we can't do that, can we? How come we can't name this angle B?
Because.
Because there's two of them.
There's two angles there, isn't there? That doesn't make any sense. So we want to name this angle first. Somebody name that angle for me.
C. ABC.
Angle ABC. Now, angle ABC is congruent to which angle in the other triangle? Be careful. BCD would work. So starting here, BCD. It's the ones with two marks, right? Then what other pair of angles do we still have to name? We did the one mark ones, we did the two mark
You
ones,
gotta do the triples.
3.
the three mark ones. So name this angle for me.
ACB.
Does everybody see that? You got to be able to name these angles. A lot of people messing them up on the exam. A, C, B. And what's it congruent to?
DBC.
D, B, C. Make sure you're using your symbols. Now, we named all the angles that are congruent. What else do we still have to name?
Lines.
All the what?
Lines.
Segments.
Thank you. Lines can't be congruent. Pick me a segment in this first triangle.
AC.
So, if I'm just looking at the name here, segment AB, what's it match up to in the other one? Does everybody see that you can just do it from the names? Do I really need the drawing? Segment BC, what's it match up to?
BD. Yeah.
Random, you let me know.
No.
Did we write it down wrong?
AC.
No.
BD.
No.
Look at them. Like, segment
Now,
I think
AC.
Miranda was a step ahead of us. But she didn't name the first one the first time, so that confused everything. Now, I took the first two letters, I took the second two letters, now I need to take the first letter and the third letter. That's AC, right?
Oh.
And it's congruent to what? BD or DB. Does it matter which way you name those?
Oh.
No, it makes no difference. This, it matters. This, it doesn't make any difference. They don't have to match up that way. What's these arrows tell us? Parallel. As soon as you see that, we're going to use this a lot. If those two are parallel, look at what happens when I do this.
Interior something.
Alternate interior angle. So what do I know about this angle and this angle?
Same.
So mark them. Mark those congruent. What's these double arrows tell us?
Parallel.
Parallel.
Different parallels.
So if I do this, if I trace those, what it's formed again?
The other
Z.
ones.
So what do I know about these two angles? So I mark them congruent.
A little higher. Right.
Now, they might be right angles, I'm not sure about that, but we did just have a theorem that said we have two triangles here. If this angle's congruent to this one, this angle's congruent to that one, what has to be true about these other angles? They have to be congruent. And we'll make Gavin happy by putting the one arc and the tick mark on it that he wanted earlier. Now, we know all the pairs of angles are congruent. Are all the sides, all the corresponding sides congruent? Yes, no, maybe?
Maybe. Not.
We got, what's that tell us about these two? Congruent, how about these two? Congruent? That's two pairs. What are we missing?
Middle.
What do we know about segment KM in the bottom triangle?
They're the same.
It's the exact same segment, reflexive property. Anything equals itself.
Just do 3 lines.
So put 3 on it. Is that enough to say these two triangles are congruent? Name the triangle down here for me.
KJ and
KJM. Now be careful. What's K match up to?
hold on.
M.
Yeah.
What's J match up to?
L.
L. MLK.
And what's
K.
M over here match up to? K up here. You gotta spin it around, right? That's our congruency statement. We're not gonna match up all the stuff. You guys think you can handle those? Those are boring, aren't they?
Very.
Everybody think Ethan K, you think you can match up the triangles?
Sure.
You don't think you can? Is it just Ethan K or is it for all Ethan?
All of us.
All Ethan. So just write down 3 and 4, we'll skip those. Same thing. 5, write down 5, we'll skip it. I could tell Cooper was getting bored since he's my favorite. We'll skip over those.
So we're skipping 3, 4, and 5.
We're skipping 3, 4, and 5. Just right in there. Ebersole said skip.
Yeah, I just.
Problem 6 and 7 go together. I think they say find X and find Y.
Yeah.
Look at these two triangles. How could we find one of them? I don't care which. One of them's pretty easy.
Y is 48.
Does everybody agree with Miranda? Yes, no, maybe?
Yes. Sure.
So that's one of our answers, so that was pretty easy. Now what? How are we gonna find X?
We're going to check. Wait, where is that stop?
Fill in the Y's on the right triangle.
So this is 48.
And then fill in the other one.
That's 48.
And then the 108 is also.
This is 108. So we'll fill that in.
48 plus 108 plus 2x minus 48.
So all 3 of these angles should add up to 180. Now, could we do some of this beforehand? What's 48 plus 108?
It's 160.
156.
156. Let's go ahead and subtract that from 180.
24.
What is it?
44.
24?
24.
So what's this angle right here? How much is it? 24 degrees, right? That's what you guys just told me.
Yeah.
Yeah.
So now what's this have to equal?
24.
Might that be a little easier to do? That's up to you guys. If I just confuse you, then don't do it that way. Go ahead and do this plus that equals 180. Add 48 to both sides, help me out. 72. Divide by 2. 36. So x equals 36, y equals 48. What's the measure of angle A over here?
24.
They didn't ask us for that, but we know it. Next one. 8, 9.
Well,
6 and 7 were the same problem.
what are you doing?
X was one and then Y was the other. No, X was one of the,
That's confusing.
so number 6 was 36, number 7 was 48, is that right?
Something like that. 6 was
What do we have to do to these two quadrilaterals to get them to match up? Flip them around. So give me an equation that we could set up.
What?
Huh?
Give me an equation. If they're congruent to each other, give me an equation that we could set up to solve for x or y.
Oh,
Oh.
12 equals 3x minus 3.
Equals what?
3y minus 3.
Everybody agree with that?
Yeah.
This
That makes more sense.
equals that.
Just divide.
Somebody solve that for us. We'll come back to it in a second. How could we find x? What equation could we set up? I know I'm probably going to use the 2x plus 4. What's this angle equal?
100.
It equals that angle right there. If you flip it around, that's the ones that match up, right? Anybody get y yet?
5.
Anybody get x yet?
52.
Well, that don't sound right.
Wait.
That's right. What's up?
Yeah.
Wait,
No,
no.
it was wrong.
It's 96 divided by 2.
Yeah. 48.
48? Does everybody agree with that?
Yeah.
Ten, 11, skip them.
Say what 8, 9, 8 is.
So which one's 8? I don't know which one's which. We confused everybody with our x and y.
8 is x equals 48, and 9 is y equals 5.
So that's number 8, that's number 9. Nick, you get it? This one's 8, that's 9.
5.
Make sure you tell Gavin. Nick, did you get it? He got annoyed pretty quick, didn't he?
Yeah.
He wonders why people get annoyed with him pretty quick. Number 12. What do they tell us in number 12, real quick?
Camilla is designing a new image for cell phone cake. If the measure of angle ABC is
Oh, slow down.
35,
ABC, so that's this angle right here. Is how much?
35.
35.
The measure of angle BAC is 29,
Okay?
and the measure of ACB is congruent to angle DEB.
Okay?
What is the measure of angle DEB?
So we want to find that angle right there. How could we do that?
Well, we just need to find the other angle of that.
The other side of B is 30.
So that's true over here, it's 35 also, isn't it? So we could put that over there if you wanted. Could we find this angle that I just pointed at?
Mhm.
Yeah.
29 plus 35, what's that?
So 65.
65?
64.
64? Which one is it?
44.
Then what do you, so that angle's 64?
You gotta subtract that.
Subtract it from 180? What's that give us?
116.
116, is that right? Yes, no, maybe?
Yes.
So if that's angle 116, if that angle's 116, what do we know about those two angles? They're the same, they're congruent, they told us they were congruent, so that's 116 also. What can you tell me about this angle down here? 29. Now I hope Gavin knows that, and I knew what he's talking about, but should he name that angle D? No. Angle EDB is 29 degrees. You're going to turn that in here in a few minutes. Go back to your notes, set that off to the side. We're going to go extremely quickly now. It was 116. 116.
116.
It's 116. Find this on your notes, fill it in. We did this last time. Isosceles triangle. What's an isosceles triangle?
At least two sides.
At least two sides congruent. What's an equilateral triangle?
All three sides are the same.
All three sides are congruent. Every equilateral triangle is also a what? Isosceles. Is every isosceles triangle an equilateral triangle?
No, it can't work.
Now, some books, again, they're going away from that. They're saying, no, isosceles and equilateral triangles don't mix. They're never the same. So you may have some math teacher down the road tell you that Ebersole lied to you.
Mr. Harrison was
And when Cooper comes back and tells,
lying. Mr. Harrison lied to us on the first day. So how are we supposed to know that anything he said was true?
Yeah, he said he had photographed me.
Well, no, that part's actually kind of true. But when he
Oh, it's
said he memorized the whole book, well, kind of true.
And there's about
When he said he memorized the whole book,
Oh.
lie. Yeah, and all the stories.
What?
Yeah.
Looks like
It was
looks
really
like we
good.
already answered
I
that.
saw that.
don't put your stuff away because we're going to get through everything regardless.
In here, I swear to God, he said.
On this, an isosceles triangle.
The
Diamond
digging.
Didn't say it.
An isosceles triangle. When you write this down, once my screen comes back up,
You probably should throw the bad marker away.
Raining.
these two sides, and I think they got arrows like pointing at it like from right here.
Yep.
Those are called the legs. So fill that in. The third side is called the base.
It says blank or legs.
Fill that in.
Blanks or legs?
You see the picture?
Yeah, you're filling in the picture.
Open up your eyes and listen.
Ooh.
Oh, she broke.
Did mess up again. This angle is called the vertex angle. You got to know these names. If you don't know these names, you won't be able to do the problems that deal with an isosceles triangle. Jacob, do me a favor. Get that. Turn it off again and turn it back on. The other two angles. These two angles down here at the bottom. I think they got arrows going like this or something. Are called base angles. Please don't think that the base always has to be on the bottom. This triangle is an isosceles triangle. Is the base this side? No, the base would be this side. All right? So don't think that the base always has to be on the bottom. The base angles. Mark it like this. The base angles must go ahead. The base angles always must be congruent. The legs always must be congruent. Once this comes back up, we'll fill in the other parts. Which parts are the legs in this picture?
Line A, B, and line AC. Segment.
Thank you. So segment, hang on. segment AB and segment AC are the legs, and they're always congruent to each other. That's the legs right there. Which segment's the base? CB will work, DC would work. That's the base down there. This right here, angle A, is the vertex angle.
I put 10.
And you could name it with 3 letters if you wanted. Probably better to name it with 3 letters because that's the way we have to do it most of the time. And then these 2 down at the bottom are the base angles. And they're always congruent to each other. Gotta know those names, because in the problem, what they're gonna do, they're gonna say, triangle ABC is an isosceles triangle with vertex A. Then you gotta know, this is the vertex angle, these other 2 are the base angles, and you gotta be able to pick out where the legs are. And for vertex angle, you might wanna put right here, the vertex angle is always between the 2 legs. The vertex angle is always between the 2 legs. You're all right. Just wanna pay attention. Isosceles triangle theorems say this, easy stuff. Draw this picture. If a triangle is isosceles, if it has 2 sides that are congruent. Guess what's true about these 2 angles down here?
Same.
They're congruent. The other one's the converse of that. If the 2 angles are congruent, guess what you know?
2 legs are the
The 2 sides are congruent. Now you'll see me, and that's what the next picture is. You'll see me every time I do this. I don't even think about this. This is just a shortened way when we do these 2-column proofs to give you something short to write as a reason instead of writing out some big long thing.
Do the 2-column proofs, can you draw the picture?
Yeah. And so on this, when we're doing this, I usually just draw in the arrows. If these 2 sides are the same, then what do I know about these 2 angles? They're the same. The ones across from them. In any triangle, if 2 sides are the same, the angles across from them have to be the same. An equilateral triangle, last thing. If a triangle is equilateral, we said this last time, then it's also what?
equal angular.
Equiangular. If a triangle is equiangular, then it's also equilateral. Works both ways. If I tell you this triangle is equilateral, tell me something you know about it.
It's equiangular.
That's true. What else?
All sides.
All sides are the same, so mark this picture.
All angles are the same.
All angles are the same, so mark the angles. Now, not only are all angles are the same, but you can give me a little more information.
60 degrees.
All angles.
They're all 60 degrees. If the triangle's equilateral, then each angle is always going to be 60 degrees. My triangle here, is it equilateral?
Yeah.
No. Is it isosceles? Yeah. Now this is actually, I'd probably give somebody a candy cane if you can guess this name.
A right triangle.
This actually has a special name.
Jameson?
Good for it.
Scalene?
A perfect triangle.
It's not right.
It's
Can I ask
wrong
Google?
triangle.
Quarter square?
It is the right triangle.
You already told me it was isosceles, didn't you?
Yeah, it's a
Henry,
square
did you say
triangle.
quarter square?
Now James was sort of half right.
Half of a square.
That's not what James
It's
said.
not.
4 of them will make a square too.
So are we giving up?
Oh.
I get to keep my candy cane? That's what I needed.
Yeah. Isosceles?
It's
Was this in yesterday?
You and Jameson need to get together.
Isosceles triangle? Isosceles right triangle. I said it backwards from that. I said isosceles right.
So it's a isosceles right triangle. Because not only is it isosceles, but it also has a right angle in it. What can you tell me about this angle, these two angles in this triangle?
They add up to 90 degrees.
They're congruent. They add up to 90, and they're what?
45.
They're 45
No one
degrees.
needed the number for
What if I grab Nick's triangle here?
Same thing.
What can you tell me about this angle?
45.
45 degrees. Now, is that going to work for every single triangle?
No, but it would be nice if it did.
Only isosceles right triangles. Guess what kind of triangles we use a lot in the real world?
I saw.
Isosceles right triangles.
Scaly.
Left triangle.
Dude, we get a candy cane.
Do me and James.
Yeah, I guess.
We
Well, I got a happy
You
James.
got it.
At least.
You said.
I think you guys can handle all these
Giving
examples.
us.
You guys can handle the example, okay?
Yeah.
Let's do the last one.
That piece of insulation or brick?
I thought that was a cell.
What's these two arcs tell
I
us?
thought it was
They're
too.
congruent.
Those are congruent.
Oh, what's that?
Those two are congruent. Well, if those two are congruent, what do you know about the sides across from them?
They're congruent.
They got to be congruent. So what equation could we set up?
X plus 4 is equal to 4x plus
Plus
1. Yeah.
Okay.
Subtract x on both sides. You have 4 equals 3x plus 1. Subtract 1.
X equals 1.
Divide by 3. What's x equal?
1.
Is that what they asked us to find? What did they ask us to find? So how are we going to do that?
17.
Plug in 1 right there. How long is this side?
5.
5.
So that means the other one's
So the other
5.
one's got to be 5. Then what are we going to do with all 3 of those?
Math it together.
And what's that give us? 17.
How is the other one? That don't
17
add up.
inches.
Yes, it does.
17.
On the bottom?
4 times
Inches.
1 is 4.
Oh, yeah.
Plus 1.
So the perimeter of the sandwich is 17 inches. Just for James.
Boom.
Boom.
Homework.
Boom.
393.
Not a very long assignment this time. It's not real difficult.
Nice. Triangle.
Was that a sandwich or a piece of wood?
I knew it.
All right, going back and doing these examples.
It's messed up.
This says find all sides and all angles. Just look at this first triangle. All these tell us that this is an equilateral triangle. So if this side's 12, that side's got to be 12 feet, and that side's got to be 12 feet. And if it's equilateral, that means it's equiangular. So that means every angle's got to be 60 degrees. So that's all the sides, all the angles. Next one's equilateral. Again, so that means all these angles are 60 degrees. Just fill those in. And all the sides, well, they didn't tell us one of the sides, or all the sides this time, so we just got to set up an equation. We know that these two sides have to be equal to each other, so 4x minus 2 has to equal 3x plus 3. Subtract 3x on both sides. End up with x minus 2 equals 3. Those cancel out. Add 2 to both sides. End up with x equals 5. They didn't want us to find x, they wanted us to find each side, so I take 5 and I plug it back in over here. 3 times 5 plus 3, 3 times 5 is 15, plus 3 is 18, so that means this side's 18. Well, if that side's 18, then this side has to be 18, and that side has to be 18. On this one, they say, my segment's got moved here, that segment should be there, and that segment should be there. If segment AE, that's this segment, is congruent to segment DE, what angles are congruent? Well, what you have to do here is you sort of have to get rid of these two in the center here. So we're just looking at this triangle. And they tell us this segment's congruent to that segment. And every isosceles triangle, if those two sides are congruent, then those two angles have to be congruent. So in this picture, that'd be this angle is congruent to that angle. And I'm going to name it with 3 letters. angle EAB, and there's other ways you could name it, has to be congruent to angle EDC. So two sides in a triangle are congruent, two angles have to be congruent. Now I'm going to erase everything on this so I can do this next problem that uses that same picture. It says angle D, that's this angle, is congruent to angle CED. CED, that's this angle. So we're just really dealing with, and that's horrible drawing, we're just really dealing with this triangle over here on the side. That's E, that's C, that's D. And we know that these two angles are congruent. That means the sides across from them have to be congruent. Well, this side across from that one is side or segment CD, and it has to be congruent to segment EC. So that's just using that isosceles triangle theorems. Next it says find X. If we look at this, they tell us that these three angles are congruent. That means it's an equiangular triangle. Well, if it's equiangular, all these angles are 60 degrees. That means it's also equilateral, so all these sides are congruent. Well, if this side's 12, then X over here has to be 12. So that was pretty easy. This one, they tell us these two, or all three of these sides are equal. It's equilateral. Well, if it's equilateral, then it's also got to be equiangular, so that means every angle is 60 degrees. So in this case, X equals 60. A little tougher on this one. You might want to separate these when you're doing a problem like this. I might separate off this triangle over here on the left. That's 8y, that's 40. And we know that these three angles are congruent. So that's 60, that's 60, that's 60. And if those three angles are congruent, then that means all three sides are congruent. If it's equiangular, then it has to be equilateral. If all three of those sides are congruent, then 8y has to equal 40. We just divide both sides by 8, and we end up with y equals 5. That's one of our answers. So we now know that this side is 40. We know this side's 40. We know this is 60. We know this is 60. We know this is 60. I'm just filling in stuff because I wasn't sure what to do next to help me find X over here. But if I split off that triangle, and X is right here, this side over here is 40. Well, we also just found out that this side right here is 40. That means that they're congruent to each other. So this is an isosceles triangle. And if it's isosceles, then that means that these two angles have to be congruent. So we know this angle is congruent to that angle. Looking back at the original picture, I still need a little more information. Well, I know that these two angles here are supplementary, so if that's 60, this has to be 120. If that's 120, and these two angles are congruent, then I can take 180 minus 120, and I get 60. Each of these angles isn't 60, the two of them together are 60, and we know that they're the same, so we just take 60 and divide it by 2. So each angle has to be 30 degrees. So we know that X equals 30. The sandwich, I already did the sandwich earlier, jumped over it and did it. Again, the assignment, there, it's on your notes. Page 330, 6 through 15, 20 through 23.